So, good afternoon, everyone. So, in the previous class, we have started a new chapter that was electric potential and capacitance. And I think I have discussed capacitors connected in series, if I'm not wrong. Okay, again, we'll start with that capacitors connected in series and parallel. We'll try to finish this particular topic today itself. So, what is the new chapter that we have started for SAQs? Electric potential electric potential and capacitance. Electric potential and capacitance. This was the new topic that we have started in yesterday's class. I think we have discussed the arrangement of capacitors. So yesterday we have seen series combination of capacitors. Series combination of capacitor. So what was the series combination of capacitor? We've seen that. Let us consider three capacitors. This was the first plate of first capacitor. This was the second plate of first capacitor. This was the first plate of second capacitor. And this was the second plate of second capacitor. This was the first plate of third capacitor. And this was the second plate of third capacitor. And what I said, in order to define this, I said that second plate of first capacitor is connected to first plate of second capacitor. Similarly, second plate of second capacitor is connected to first plate of third capacitor. This type of arrangement was called as what? Series combination of capacitors. And further, what we did, we have derived a formula for equivalent capacitance. Equivalent capacitance. What was the formula for equivalent capacitance in case of series combination? It was 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So this was the last topic that we have did in yesterday's class. Now we are going to continue this topic. We are going to study about arrangement of capacitor in parallel combination. Then we'll obtain a formula for capacitance of parallel plate capacitor. Now let us start our class today. See here. Next topic in this is parallel combination of capacitors. Parallel combination of capacitors. First of all, you are supposed to draw the diagram. Once you are done with the diagram, we can easily obtain an expression for parallel combination of capacitors. Now everyone see here. Let me again consider three capacitors. This is my first capacitor. This is my second capacitor. This is my third capacitor. What I am doing? I am considering 2 points here and joining all the first plates of all capacitors at one particular position A and joining all the second plates of all the capacitors at one particular point B. So this is capacitor of capacitance C1. This is capacitor of capacitance C2. This is capacitor of capacitance C3. So this type of combination of capacitors are called as what? Parallel combination of capacitors. How you are supposed to define this parallel combination of capacitors? First plate of all the capacitors are connected at one terminal A, and the second plates of all the capacitors are connected at other terminal B. Then this type of combination is called as what? Parallel combination of capacitor. Again, what I am doing? I am connecting this terminal to positive potential. I am connecting this B terminal to the negative potential of the battery, which is having some potential V. Now carefully see here, we are going to obtain an expression here. So what I did, I have considered three capacitors which are arranged parallelly, and all the one side terminals are connected to positive terminal of the battery. All the second plates of the capacitors are connected to negative terminal of the battery. Now see here, again what will happen? Charge will flow. Now this charge Q gets divided here. At this junction, what will happen? The charge will get divided. Assume that the charge flowing through C1 is Q1, the charge flowing through capacitor C2 is Q2, and the charge flowing through the capacitor C3 is Q3. So what is the total charge? This is Q is the total charge, and this charge Q is getting divided into how many charges? Three charges, Q1, Q2, Q3, flowing through the capacitor C1, C2, C3. Now we know that, what we know? We know the formula for capacitance. What is the formula for capacitance? C is equals to Q divided by V. C is equals to Q divided by V. Now everyone see here, what is the total charge here? Total charge Q is getting divided into how many components? Three, Q1, Q2, Q3, which are flowing across the capacitors C1, C2, C3. So what this will become? Q is equals to Q1 plus Q2 plus Q3. So by looking at this equation, I can write that what is the value of Q? I can write Q is equals to C into V. I can write charge Q is equals to capacitance C into potential V. Let us substitute this value here. What this will become? This will become CV is equals to, what is the capacitor at charge Q1? C1 is the capacitor at charge Q1. So this will become what? C1 into V. And Q2 is the charge flowing through which capacitors? C2. So this will become what? C2 into V. Again, finally, Q3 is the charge which is flowing through the capacitor C3. What this will become? This will become C3 into V. So what is the thing I can take common here? I can take potential common. So this will become V into C is equals to V of C1 plus C2 plus C3. What will happen here? V and V get cancelled. Finally, I can write equivalent capacitance in case of which type of combination? Parallel combination, as C1 plus C2 plus C3. This is the end of this answer. So in the previous class, in yesterday's class, we have seen the series combination of capacitor, and in today's class, we have seen the parallel combination of capacitor. Based on this topic, many times they have asked the numerical in the examination. Let us solve those two problems. Once we are done with that problem, we'll move on to the next important executions from this chapter. Okay, I hope everyone is copying, writing this. Now let us discuss numericals. So let me see the question. Please note down this question. Numerical. First numerical, which may be asked in your examination. Three capacitors of 2 picofarad, 3 picofarad, 4 picofarad are connected in parallel. Now what he is asking you to determine, he is asking us to calculate. First question in this, what is the total capacitance? What is the total capacitance of the combination. And what is the next question he is asking in second question? Determine the charge. Determine the charge. Determine the charge on each capacitor. On each capacitor if 100 volt supply is connected. If 100 volt supply is connected. Now see here, this was the question which was asked in previous year examinations. What is the question? There are three capacitors, 2 picofarad, 3 picofarad and 4 picofarad are connected in which type of combination? Parallel combination. Next, what he is asking you to determine, he is asking you to calculate the total capacitance of the combination, and he is also asking you to determine the charge on each capacitor. हर capacitor के ऊपर कितना charge flow हो रहा है determine करो बोल रहा. Now see here, just now we have seen this was the parallel combination of capacitor. What is the formula we got for parallel combination of capacitor? C equivalent is equals to C1 plus C2 plus C3. Now let us apply here. First of all, answer. I am writing the first answer. A. How many capacitors he has given? He has given 3 capacitors. What are those capacitors? Capacitance C1 is equals to 2 picofarad. 2 picofarad. C2 is equals to 3 picofarad. And C3 is equals to how many picofarad? 4 picofarad. What is the first question he is asking you to determine? Total capacitance of the combination. How they are connected? They are connected in parallel. So I know that C equivalent is equals to C1 plus C2 plus C3. This question will be asked for 4 marks. So you are supposed to write down the given quantities as well as the formula also. So this is the formula. For writing the formula, you will be getting 1 mark. So see here, equivalent capacitance. What is the formula for equivalent capacitance? C equivalent is equals to C1 plus C2 plus C3. Okay, very good. Then let us substitute this value. C equivalent is equals to, what is the C1? 2 picofarad plus what is the value of C2? 3 picofarad. And what is the value of C3? It is 4 picofarad. So what will be the final answer? Equivalent capacitance is equals to 469. 9 picofarad. This is the answer for the first question. What was the first question? He was asking you to determine the equivalent capacitance whenever the 3 capacitors are connected in parallel combination. So let us see what is the next question. Second question. What is that? He is asking you to determine charge on each capacitor whenever a potential of 100 volts is applied. Again, I am writing. How much potential he has given? V is equals to 100 volts. He is asking you to determine charge through C1, C2 and C3 capacitors. We know that in case of parallel combination, potential remains same. At this point, whatever potential is here at A and B, the same potential will be here. In parallel combination, what will be constant? Potential will be constant. So I can write Q is equals to C into V. This is the general formula. C is equals to Q by V and charge Q is equals to C into V. Now, charge on each capacitor. Charge on first capacitor is given as Q1 is equals to C into C1 into V. That is nothing but, what is the value of capacitor C1? It is 2 picofarad. Pico means how much? 10 power minus 12 into how much potential is there? 100. So what will be our answer? This will become 2 into 10 power minus 10 coulombs. What is the unit for charge? Unit for charge is coulomb. So if I want to calculate the charge through capacitor C1, what will be our answer? Our answer will become 2 into 10 power minus 10 coulomb. Charge through second capacitor, what will be the formula for charge through second capacitor? Q2 is equals to C2 into V. What is the capacitor? C2 capacitors? capacitance of C2 capacitor? 3 picofarad. Pico means how much? 10 power minus 12 into how much potential we have applied? 100 volts. So this answer will become 3 into 10 power minus 10 coulomb. Finally, charge flowing through third capacitor is given as C3 into V. So what is the capacitance of C3 capacitor? 4 picofarad. 4 into 10 power minus 12 into how much potential? 100. So what is our final answer? Our final answer will become 4 into 10 power minus 10 coulomb. So this is the end of the first numerical based on capacitance. And here which type of combination is there? Parallel combination is there. Which type of combination is there? Parallel combination is there. I hope you understood this answer. Let us move on to the next numerical which may be asked in the examination. See here, let me note down the question. Second numerical from electric potential and capacitance. See here, three capacitors, each of capacitance 9 picofarad are connected in series. Okay, now what he is asking you to determine after giving this statement? First question, what is the total capacitance? What is the total capacitance? What is the total capacitance of combination? What is the next question he is asking? He is asking you to determine potential difference across each capacitor if the combination is connected to one 120 volt supply. So this is the another important question from this electric potential and capacitance. Now let us solve this. Previously we have did the problem based on parallel combination. Now we are getting the problem based on which type of combination? Series combination. First of all, let us write down the given quantities. Answer. What are the given quantities? He is telling that there are three capacitors. All the three capacitors are having capacitance how much? 9 picofarad. So I am writing capacitance C1 is equals to 9 picofarad. Capacitor C2 is equals to 9 picofarad. Capacitor C3 is having a capacitance of what? 9 picofarad. So what is our first question? Question number A. What is the total capacitance of the combination? Whenever capacitors are connected in series, what is the formula for equivalent capacitance? What is that formula? 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is in which case? Series combination. So let us apply this formula. So what is the formula? 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. For writing the formula, you will be getting the marks. So wherever you are writing the formula, you will be getting 1 mark for this. Now let's substitute the value. 1 by C equivalent is equals to, what is the value of C1? C1 value is 1 by 9 plus 1 by 9 plus 1 by 9, because all of the three capacitors having same capacitance. So 1 by 9 plus 1 by 9 plus 1 by 9, how much it will become? It will become 3 by 9. So 3 ones and 3 threes. So what will be our final answer? Our final answer will become C equivalent is equals to 3. What is the unit we are getting here? Picofarad. 3 picofarad. So equivalent combination in case of series is what? 3 picofarad we are getting. So what is the formula? 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. All the three capacitors are having same capacitance. What is that capacitance? 9 picofarad, 9 picofarad and 9 picofarad. If I am adding that, I am getting what? 3 by 9. So finally, what is the equivalent capacitance I am getting? 3 picofarad I am getting. Okay, good. Let us solve the second question. What is our second question? He is asking you to determine the potential difference across each capacitor if the combination is connected to what? 120 volts power supply. So here, given voltage is how much? V is equals to 120 volts. Okay. What is the formula for equivalent capacitance we got? C equivalent is equals to how much we got? 3 picofarad. What is asking you to determine? Potential difference across each capacitor. So what is the formula? We know that formula is C is equals to Q divided by V. From this I can write V is equals to Q divided by C. V is equals to Q divided by C. So I can write potential across the first capacitor as V1 is equals to Q divided by C1. I can write or not? V1 is equals to Q divided by C1. First of all, we should know the value of Q. So from here I can write Q is equals to V into C equivalent, as same amount of charge will flow in series combination. There is no division of charges. That is the reason, first of all, I am determining the charge Q. So Q is equals to how much potential difference is here? 120 into how much capacitance we got? 3 picofarad we got. So this will become what? Q is equals to 360 picocoulomb. What is the unit of charge? Charge ki unit hai coulomb. So 360 picocoulomb. Let us substitute this value here. This will become 360 divided by what is the value of C1? 9 picofarad. 9 picofarad. Picocoulomb. So here we'll be getting 9 ones and 9, 40. So this will become how much? 40 volts. So voltage across capacitor C2 is given as what? Q divided by C2. Here also the same charge, 360 divided by, and what is the second capacitance? Three capacitors are having same capacitance. So this will become 9. Again, I will be getting 40 volts. Similarly, for V3 also, what we are getting? Q divided by C3. That is nothing but 360 divided by 9. Again, I will be getting 40 volts. So the potential across each capacitor is same wherever three capacitors connected are having equal capacitance, 9 picofarad capacitance. I hope you understood this answer. So here we are done with the problems of series and parallel combination. Initially, we have discussed about the series combination. What is the equivalent capacitance when the capacitors are connected in series? Next, we have discussed what is the equivalent capacitance whenever capacitors are connected in parallel. Finally, we did two numerical based on those two concepts, and we are done with this. Now let us move on to the most important question or most important topic from this chapter, that is capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. Most important question, most important topic for your annual examination. Most important topic for your annual examination. Now everyone carefully see here. Here, which type of capacitor is here? We are having parallel plate capacitor. We are having parallel plate capacitor. Let us draw the circuit diagram or diagram for this parallel plate capacitor. Let me consider one parallel plate which is arranged something like this. Okay. Next, let me consider one more capacitor which is arranged something like this. Otherwise, I will take this one. See here, there are two capacitors. One plate is arranged something like this. I am considering one more plate which is arranged something like this. The distance between these two capacitors is D. Both of them are separated by a small distance D. This capacitor is having some plus charge on it. This capacitor is having some plus charge on it. And the capacitor below this is having negative charge. Here we are having negative charges. Here we are having which type of charge? Negative charge. Both of them are separated by a small distance D. Now we know that whenever there are positive and negative charges, an electric field will flow from which region to which region? Positive region to negative region. This is the direction of electric field. Here the electric field is flowing from positive to negative region. Assume that this surface is having some surface charge density sigma. I hope everyone know what is the definition for surface charge density. Charge density के कितने types हैं हमारे को? We are having three types of charge densities. That is called as linear charge density, surface charge density, and volume charge density. What is the meaning of surface charge density? Surface charge density is given as sigma is equals to charge per unit area. Amount of charge present at this particular unit area. So surface charge density is defined as charge per unit area. So here we are having surface charge density sigma. Okay. Now let's solve this question. Everyone carefully see here, within 4 points, we can solve this answer. First of all, what we did, we have considered two parallel plates which are separated by a small distance D. One plate is having, let me number this. This is the first plate. This is second plate. The first plate is having positive charge and the second plate is having negative charge, and the surface charge density is what? Sigma. Sigma is nothing but what? Charge per unit area. Now let us write down the formula for this. Let us derive the formula for capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. Everyone see here. We know that by using Gauss law, we can obtain an expression for electric field due to a plane sheet of charges. What is the formula? Electric field at first plate E1 is given as sigma divided by 2 epsilon naught. You remember this directly because in application of Gauss law, we will be deriving this formula for electric field due to a plane sheet of charges. What is that? E1 is equals to sigma by 2 epsilon naught. Similarly, electric field due to this will be sigma by 2 epsilon naught. This is second plate. What will be the net electric field? Our net electric field will become E net is equals to E1 plus E2. What this will become? This will become sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So finally, I can write net electric field. Net electric field between a parallel plate capacitor is given as what? Sigma by epsilon naught. But what is the value of sigma? Sigma is defined as charge per unit area. So this can be written as sigma Q divided by A epsilon naught. This is the first point in the answer. Next point. First, what we did? First, we have calculated the electric field between the parallel plate capacitor. Next, what we are going to calculate? We are going to determine the potential, because one positive charge is there, one negative charge is there. What will exist between them? A potential difference V will exist between them. We know that what is the formula for V in terms of electric field and distance D? V is equals to E into D. So what is the value of E we got? Q divided by A epsilon naught into D. This is the second point. Now we are done with the 2 points. Final point will be our answer. What we are supposed to determine? We are supposed to determine the capacitance of parallel plate capacitor. Third point. What is the formula for capacitance of a capacitor? C is equals to Q divided by V. Let us substitute this value. What is the answer we'll be getting? C is equals to Q divided by, what is the value of V got? Q into D divided by A epsilon naught. What we are doing, we are just substituting the value of V here. So this Q and this Q will get cancelled. Finally, the equation or the expression for capacitance of parallel plate capacitor is given as C is equals to, this A epsilon naught will go to numerator. This will become what? Epsilon naught into A divided by D. So this is the expression for capacitance of parallel plate capacitor. Very important question for your annual examination. I think in the previous examination also they have asked this question, capacitance of a parallel plate capacitor. So what I did, I have considered two parallel plates which are separated by a distance D. On the one surface of the parallel plate, what I have considered a positive charge. On the other surface of a parallel plate, what I have considered the negative charge. And we know that wherever there are positive and negative charges, electric field will start to flow from positive charge to negative charge. As the charges are present on the surface of one particular area A, I can define a term that is called as surface charge density. What is the name of this? Surface charge density. Surface charge density. So what is the definition for surface charge density? It is defined as charge per unit area. So here we'll be having one electric field E1 due to positive charge. Here we'll be having an electric field E due to plane sheet of charges. So our net electric field will become what? E is equals to sigma by epsilon naught. And we know the value of sigma. Sigma ki value kya hai? Q by A. Next, what we are supposed to determine? The potential developed across this capacitor. And what is the formula for that? V is equals to E into D. Already we have determined the value of E. What is the value of E? Q divided by A epsilon naught into D. So finally, what we are supposed to determine? We are supposed to obtain the expression for capacitance. So what is the formula for capacitance? C is equals to Q divided by V. What I did, I have substituted the value of V here. Finally, I am getting an equation which is the expression for what? Capacitance of a parallel plate capacitor. I hope you understood this. So let us move on to the next topic from this chapter. Next important topic from this chapter. See here. We'll study about electric potential and expression for electric potential due to point charge. Electric potential and its expression due to a point charge. Due to what? A point charge. Its expression due to electric potential and expression due to what? A point charge. So let us first of all understand what is the meaning of electric potential. Electric potential hai kya? See here. Let me consider one charge Q here. There is one charge Q. Now, at one particular distance R, there is one point P. There is one point P. I am having one charge at infinite distance. Which type of charge? This is always we are considering which type of charge? Unit positive charge. Unit positive charge. I am having a unit positive charge at infinite distance. Where? At infinite distance. Now, what I am supposed to do? I want to bring this charge to this particular position P. What I am supposed to do? I am supposed to do some amount of work. So, in order to bring this charge from this particular infinite distance to one particular point P, what I am supposed to do? I am supposed to do work. So, we can define electric potential as, electric potential is defined as work done in bringing a unit positive charge from infinite distance. Work done in bringing a unit positive charge from infinite distance. So what is the definition for electric potential? Electric potential is defined as work done in bringing a unit positive charge from which distance? Infinite distance to a particular point P or a particular position P. I hope you understood the definition for electric potential. Now, I will try to solve this answer or obtain an expression by using two different methods, whatever you feel easy, you can use that method. Now see here, expression, first method. Again, I am saying whichever you feel easy, you can do that. Now we know that electric field intensity due to point charge. Yesterday we did this. What is the formula for electric field intensity due to point charge? We know that it is given as E is equals to Q divided by 4 pi epsilon naught into R square. Everyone know this formula. Yesterday we have obtained the expression for this what is defined electric field intensity. Obtain an expression for electric field intensity due to point charge. And I think we got this expression. What is that? E is equals to Q divided by 4 pi epsilon naught R square. But here what we are supposed to determine? Here we are supposed to determine electric potential. And we know that there is a relation between electric potential and electric field. What is that relation? That is V is equals to minus integration E bar dot dr bar. If you are able to remember this formula, then we can directly solve this answer. What is the relation between electric field and electric potential? It is given as V is equals to minus integration E bar dot dr. So let us substitute this value. V is equals to minus integration. From which position we are bringing this charge? We are bringing this charge from infinite position. Infinite position. To which position we are bringing this charge? To a particular point P, which is at a distance of R from a charge capital Q. So I can write from infinity to R. What is the value of E we got here? Q divided by 4 pi epsilon naught into R square into dr. Now see here, charge capital Q is constant or variable? Constant. 4 pi is constant or variable? Constant. Epsilon naught is constant or variable? Constant. So what is the only variable here? R. This distance can change. This distance can change. Let us take all the constant outside and let us integrate this equation. What this formula will become? This will become V is equals to minus Q divided by 4 pi epsilon naught. From where to where the charge is coming? From infinite to a particular distance R, and this will become 1 by R square into dr. 1 by R square into dr. Let me solve the remaining answer here. Everyone carefully see here. I hope everyone know what is the formula for integration x power n. I hope everyone know this formula. What is the formula for integration x power n dx? What will be the answer? It will become x power n plus 1 divided by n plus 1. I hope everyone remember this formula. If you are able to remember this formula, then only you can solve this. So see here, what is the integration we are getting? Here we are getting integration 1 by R square. Let me solve that here. Integration 1 by R square dr can be written as integration R power minus 2 dr. What I did? I have taken the denominator to numerator. So this will become what? Plus 2 will become minus 2. Let us apply this formula. What is that? X power n dx is equals to x power n plus 1 divided by n plus 1. So this will become, in place of x, what is there? R is there. R power minus 2 plus 1 divided by minus 2 plus 1. So what this will become? This will become minus, this will become R power minus 2 plus 1 will become R power minus 1 divided by 1 minus 2 will become minus 1. So our final answer will become what? 1 by R, minus 1 divided by R. I hope you are getting this. You are not supposed to write this thing in your examination. You are not supposed to write this thing in your examination. I have just explained this, how we are getting integration 1 by R square dr as minus 1 by R. Let us substitute this value. What is the value of 1 by R square dr? Integration 1 by R square dr. What will be getting? V is equals to minus Q divided by 4 pi epsilon naught integration 1 by R square dr. What is the value we are getting? Minus 1 by R. From where to where? From infinity to one particular distance R. If I take this minus outside, minus into minus will become plus. Finally, this equation will become V is equals to Q by 4 pi epsilon naught Minus into minus, it has become plus. So 1 by r minus, I have substituted the value of r here, minus 1 by infinity. 1 by infinity will become what? 1 by infinity will become 0. So our final answer, electric potential due to point charge. Electric potential due to point charge is given as Q divided by 4 pi epsilon naught into R. So this is the final answer for determining the electric potential due to point charge. What I did, I have considered, first of all, I have defined what is electric potential. What is the definition for electric potential? Electric potential is defined as amount of work done in bringing a unit positive charge from infinite distance to a particular position P. Next, what we have determined, we are supposed to obtain an expression for electric potential due to a point charge. So what I have considered the formula for electric field intensity due to point charge. And what is the answer for electric field intensity due to point charge? E is equals to Q by 4 pi epsilon naught R square. But what I am supposed to determine? I am supposed to determine the electric potential. So what is the relation between electric potential and electric field intensity? It is given as V is equals to minus integration E bar dot D bar. From where I am bringing this charge? I am bringing this charge from infinite distance. To which position I am bringing this charge? To a particular position P, which is at a distance of R from capital Q charge. So definitely there exists some force between them. Which type of force? Repulsive force or attractive force? Here it will be repulsive force, because this Q is having positive charge. This small q is also having positive charge. Positive charge, what will happen? They will repel each other. So after substituting these values, we'll be getting this final answer. What is the final answer? V is equals to Q by 4 pi epsilon naught R. So this is the first method for determining the electric potential due to point charge. Let us see the second method also. To determine the same thing, let us see the second method. Second method to determine the electric potential due to point charge. Everyone carefully see here. See here. Let me consider one charge Q. Let me consider one charge Q. And there is one particular position, point P, which is at a distance R. Which is at a distance R. Now, I have considered two positions. This is position B. This is position A. And there is one more charge at how much distance? Infinite distance. Let the distance from charge capital Q to position A is X. What is the distance from charge capital Q to position A? It is X. Now what I am doing, I am doing some amount of work such that I am moving a charge from position A to B. How much distance I am traveling? I am traveling a distance of dx. Now everyone see here carefully. Here we have considered a unit positive charge. Which type of charge this one? This is unit positive charge. Here we are having which type of charge? Unit positive charge. Next, what I have did, I have considered, I have brought the charge to position A. Now see here. Here we are having plus Q charge. Here we are having unit positive charge. Both of them will attract or repel. Both of them are having same charges. So a force will act in this direction. What will happen? A force will act in this direction. Now what I am doing? I am doing some work. I am trying to bring the charge from position A to B. I am trying to bring the charge from position A to B. So what is the amount of work done? What is the amount of work done? I can write dW is equals to F bar dot dx. I hope everyone knows this formula. Whenever dot product is there, if I remove the dot product, which type of trigonometric function I will be getting? I will be getting sine function or cos function. I will be getting cos function. See here. I am doing the work in this direction. Force is acting in opposite direction. So what is the angle between them? Angle between them is how much? 180 degrees. So what this will become? dW is equals to F dx cos how many degrees? 180 degrees. So this will become what? dW is equals to minus F into dx. Why I have written minus here? Because cos 180 degrees what? Minus 1. Now let us determine the total work done. So I can write W is equals to integration dW, and this will become minus integration F dot dx. Minus integration what? F dot dx. From where I am bringing this charge? infinity. To which position I want to bring this charge? To a particular position A, that is how much distance? It is at x distance. But I want to bring the charge at which position? P position, which is at a distance what? R. So I'm writing it R. I'm bringing the charge from infinite distance to a particular position P, which is at a distance R from a capital charge Q. So if I substitute this value directly, I can write the answer here. See here. W is equals to minus integration. From where to where? From infinity to R. And what is the formula for force acting between two charges? The formula for force acting between two charges is given as 1 by 4 pi epsilon naught capital Q into small q divided by what is the distance between Q and this particular point A? It is x square into dx. Again, capital Q, small q are constant. I can take those things outside. This will become what? Minus QQ divided by 4 pi epsilon naught integration from where to where? Infinity to R 1 by x square dx. Just now we have seen that integration 1 by R square dr will become what? Minus 1 by R. So here integration 1 by x square dx will become what? Minus 1 by x. So directly I'm writing here W is equals to minus capital Q small q divided by 4 pi epsilon naught. So what is the value of 1 by x square dx? It will become minus 1 by x. From where to where? Infinity to one particular position R. Let us substitute these values. Let us see. Minus into minus will become what? Plus. So W is equals to QQ divided by 4 pi epsilon naught. If I substitute the value of R in place of x, this will become 1 by R, and 1 by infinity will become what? 0. So I'm getting W is equals to QQ divided by 4 pi epsilon naught R. So this is the work done in bringing a unit positive charge from which distance? Infinite distance. Now we know the formula for electric potential. What is the formula for electric potential? V is equals to amount of work done in bringing a unit positive charge from infinite distance. If I substitute this value here, what is the answer I will be getting? V is equals to QQ divided by 4 pi epsilon naught into R divided by what? Q. So this Q and this Q will get cancelled. Finally, I am getting again the same answer. Electric potential due to point charge as Q divided by 4 pi epsilon naught R. So for one particular answer, I have given you two solutions. Either you can write this solution in your annual examination, or you can write this solution in your annual examination. It's your wish. So today we have discussed two numericals and three important concepts from electric potential and capacitance. Electric potential and capacitance. So we will be left with more one or two simple concepts from electric potential and capacitance. Once we are done with that electric potential and capacitance, we'll move on to the next SAQ, that is moving charges and magnetism. Okay, before ending this class, let us see a small concept of dielectrics. Dielectrics. See here. What is the meaning of dielectric material? Dielectric materials are those materials which does not allow electric charge to flow through them easily. We have seen semiconductors, conductor, insulator. This is also a type of insulator, but here what will happen? It does not allow electric charges to flow easily. So what is the meaning of dielectrics? Material which does not allow electric charges to flow easily. So any material which does not allow electric charges to flow easily are called as what? Dielectric materials. Now let us see what will happen if I place the dielectric material in uniform electric field. Let us consider one uniform electric field here. Here we are having uniform electric field, E bar. In this uniform electric field, what I did, I have placed a dielectric material. Let us consider a dielectric material here. whenever you are placing a dielectric material in uniform electric field, what will happen? The material get polarized. What does it mean? All the positive charges will get accumulated at one particular position and all the negative charges will get accumulated at one position. So what is happening? Whenever there is a uniform electric field, what I did in that uniform electric field, I have placed a dielectric material. Due to the external electric field, what will happen? The dielectric material will get polarized. What is the meaning of polarized? All the positive and negative charges get separated at one particular point. So due to the polarized charges, all of the positive charges are at one particular position, all of the negative charges are on one particular position. We know that electric field will flow inside the dielectric material. Electric field will flow inside the dielectric material in opposite direction. I am writing this one as EI. EI. What is the external electric field? I am writing E external. And what is the electric field developed inside this dielectric material due to polarization? EI. So I can write the net electric field. I can write net electric field whenever an dielectric material is placed in uniform electric field as E external minus E internal. This is the formula for external electric field whenever a dielectric material is placed in uniform electric field. I hope you understood this. This was a small concept. Tomorrow, in tomorrow's class, we are going to discuss the potential energy of an electric dipole when placed in uniform electric field. By that, we'll finish this concept. So most probably in tomorrow's class, we are going to start moving charges and magnetism. Please do revise all the questions by, so we'll meet tomorrow. Thank you.